Hello and welcome to this webinar on protecting the Great Lakes from invasive species, how ballast water regulation can help, hosted by the Alliance for the Great Lakes. My name is Don Carr, and I am the media director for the Alliance for the Great Lakes, and also the moderator of today's webinar. Now, please note that we are recording this webinar. With a fantastic turnout today, I assume most attendees are here because you care about the Great Lakes and are concerned about invasive species. Today, we'll talk about how harmful aquatic invasive species move throughout the lakes, Canada's experience with regulating ballast water transfers to protect the environment, and what the U.S. Environmental Protection Agency needs to do to protect the Great Lakes. Today, you'll hear from Marc Gaden, Deputy Executive Secretary, Great Lakes Fishery Commission, Colin Henein, Manager and Senior Policy Advisor, Transport Canada. He'll be presenting also with Sarah Bailey, Senior Research Scientist, Fisheries and Oceans Canada, and finally, Molly Flanagan, Chief Operating Officer, Alliance for the Great Lakes. After our speakers are finished, we will open up for questions. Please put your questions in the Q&A function, and I will do my best to address each one in the time allotted. Thank you to all the presenters, and let's get started.
Hey, thank you very much, Don, and appreciate that introduction, and very pleased to join you. I'm Marc Gaden, the Deputy Executive Secretary of the Great Lakes Fishery Commission. I first started working on invasive species policy actually in the early 90s as an aide to a member of Congress when we were getting the first wave of ballast water invaders, and essentially been working in this policy area ever since with the Great Lakes Fishery Commission. My job on this webinar is to talk a little bit about ballast, what it is, and how invasive species get to the Great Lakes and spread, what invasive species do, and then why we should care about it. So let's start with the vessels, two types of vessels I'll refer to. One are called salties and the other I'll call lakers. Salties are vessels that come from outside of the Great Lakes Basin. So, they cross the saltwater ocean, hence salties. And the ballast issue with the salties is that when a vessel takes on, when a vessel is at a port of origin, it will take on ballast water as a way to have the vessel ride lower in the water and therefore provide some stability, as the schematic on the right shows. And then what will often happen, however, is that in taking that ballast water in, organisms that would be swimming around in that port might get sucked into the ballast tanks, survive the transit across the ocean. And then when they get to the port of call, the ballast is released along with the living organisms, and cargo is taken on, and that cargo serves as ballast itself. That's how invasive species have gotten into the Great Lakes. So if you have a port, for example, the Black Sea in Asia, it can suck up unwanted critters, transport them across, and discharge them into the Great Lakes. No fewer than 80 unwanted species have been linked to salties coming into the Great Lakes Basin. Since about 2006, it's been required for these vessels to what we call swish and spit. That is to exchange their ballast on the high seas so that you can dump the ballast from the port and take in fresh seawater, which we believe has reduced the introduction of new invasive species. But nevertheless, ballast water invaders coming in from salties is a serious problem. How do we know this? Well, this map shows the kind of two different points in time. The 1950s, prior to the opening of the St. Lawrence Seaway, which is how the salties get into the lakes. And then in 2020, the redder the lakes, the more invasive species are present. And you can see that of those invaders that have come into the lake, as I said, no fewer than 80 are linked to the salties. The second type of vessel are what are called lakers. And these are vessels that never leave the Great Lakes. So they transit from lake to lake, and they go from port to port. Lakers also can hold a lot of ballast water, upwards of maybe 16 million gallons per laker. And ballast serves the same purpose in a laker that it does as a salty. It provides stability. And again, you get from one port to another, and you could discharge living organisms. We know this is the case. A study in 2018 showed that ballast water discharges from lakers do spread aquatic organisms, and it is a problem in the Great Lakes. This chart shows you how we know this. There are what you see in the number there are the number of invasive species that were introduced from another lake. So the more red, the more species that have moved from one Great Lake to another. And so the Lakers and the movement of these species within the Great Lakes system continues. So for an example here in Lake Huron, 5 new non-indigenous species have been found in Lake Huron over the time series of this chart, which is 2009 to 2018. On Lake Superior, it's 11 species. So things do spread around the Great Lakes through Lakers, but also through small boats, through other human activities. You could have a boat that could go from an inland lake to another lake, or from the Great Lakes to outside of the Great Lakes basin. Sometimes these organisms also swim their way through, like shipping canals. That's why those invasive carp are such a threat, perhaps making their way into the Great Lakes from the Chicago area waterway system. But no species, then zebra mussels illustrates this, and I'll have some maps here to put into motion. Zebra mussels were first seen in Lake St. Clair in the late 1980s. 1986, you see just kind of a couple of dots in the Lake St. Clair, Lake Erie area. 1990 had spread pretty much in all 5 of the Great Lakes, a few patches up in Lake Superior. By the year 2000, not only throughout the Great Lakes Basin, but they've made their way through the certainly the eastern part of the United States. This is through canals and waterways, largely the Chicago area waterway system out toward the Mississippi, and then into the Ohio River, up the Mississippi River. And here we are in 2021, where they have pretty much spread west now of the 100th meridian and making their way to water bodies out west. There are inland lakes that zebra mussels would never have gotten to without human activities. So we do have a way of spreading these. Focus of today is about Lakers, but there's also a great need for people to pay attention to what might be hitching a ride on their boat or in their bilge tank. What is the impact of invasive species? Well, they're a nuisance. This is an aquatic invasive weed, hydrilla, that got into lakes. You can see these canoeists have to contend with that. Ecosystem disruption. Zebra mussels are low end of the food web feeders, for example. They filter plankton out of the system. So if you're an organism that eats plankton, you're going to be affected. If you're a fish that eats a fish that eats plankton, you're going to be affected. It pulls the rug right out from under the food web. That's just one example. And contributing also to an unhealthy environment. Some species that get into the Great Lakes don't do all that well in the system, or some species that get into new systems, regardless if it's fresh or saltwater, don't do so well there. Alewife is an example where it's a species that's not all that well suited to the Great Lakes. Get a bad winter, some unhealthy conditions, and they'll die off in large numbers. Invasive species are linked to the introduction of disease and parasites, as is the case in this photograph, the sea lamprey. That's a top-down invader. So zebra mussels, being planktivores, are a bottom-up, but lamprey are direct predators on fish. And that leads to, in the case of the lamprey, directly lost fishing opportunities. But for an invader that, like the zebra mussel, pulls the rug out from under the ecosystem, tremendously lost opportunities. They're linked, for example, to the loss of nutrients in the system and some declines in some commercial fish species. And then not just the ecological harms that they cause, but also significant economic costs. There are a lot of estimates out there, and depending on how you count the numbers, you'll come up with different figures, but the numbers can be quite staggering. We know that the losses economically to the environment globally is in the billions of dollars and hundreds of millions in the Great Lakes Basin. Some estimates, for example, the Eurasian ruff costs at least $300 million a year in lost economic opportunities and costs like that. The sea lamprey control program costs the US and Canada about $25 million a year. That's just to keep that under control. Without that control, it's well north of $1 billion of fish loss that we know of from the historical record on what the lamprey would inflict on the system. We're not scratching our heads wondering how these things are getting here. We're not baffled by how they're moving around the system. And we certainly are well aware of the ecological and the economic costs that invasive species cause. So I'll turn it over now to Colin with Transport Canada and Sarah with Department of Fisheries and Oceans, who will talk a bit about ballast water more particularly and what's going on in that world. So Colin, take it away.
Okay, thanks, Mark. And let me just see if I can get my presentation to come up on the screen here, or Sarah in my presentation. Let me see if I can make it bigger. Let's see here. Full screen. Can you folks see that all right?
Looks good.
Okay, great. Thanks very much. So, I'll introduce myself first here, and then I'll pass it to Sarah. So, my name's Colin Henein. I'm a manager and senior policy advisor in marine policy at Transport Canada. I've been the policy lead for ballast water in Canada since October of 2010. And I also represent Canada on this issue at the International Maritime Organization on the Canadian delegation. And my colleague for that whole period of time has been Sarah Bailey. And so really, Sarah, I'll pass it to you to introduce yourself. She's the world's expert really on ballast water and the performance of treatment systems.
Thanks, and good day to all. It's a pleasure to be here. So as Colin mentioned, I've been conducting research to assess the risk of species introductions by ballast water and the effectiveness of different management strategies for more than 20 years in order to inform decision makers in Canada. So to start this joint presentation, I'm going to briefly introduce the Canadian regulations and then share our latest findings from studies in the Great Lakes. Next slide, please. So Canada updated its ballast water regulations in 2021 to bring in requirements of an international convention on ballast water management. So essentially, these rules set a limit on the number of organisms that can be released in ballast water discharge. Most ships will use a ballast water management system to meet this standard. And the Canadian regulations apply to all ships that load and discharge ballast water in Canadian waters, including those ships that only operate in Canada. Now, the timeline to meet the regulations is different for international and domestic ships, with all new builds having to comply at launch, and the oldest Great Lakes ships having to comply by 2030. Next slide, please. So all around the world, ships are expected to install treatment technology to remove or exterminate organisms in their ballast water. These ballast water management systems operate just like treatment equipment that cleans our drinking water. So they typically use filtration to screen out larger organisms and sediments. And then there's a secondary treatment step to inactivate smaller organisms and bacteria. On the Great Lakes, ultraviolet irradiation is the most common treatment technology in use right now, though we sometimes see ships with chlorine-based systems as well. Next slide, please. During the last 6 years, my team has been studying how well different treatment systems are working. So the figure on the slide here shows the results from a typical ship where ballast water was loaded in Hamilton Harbor in July when there was a very high number of organisms in the natural harbor water. So the blue bar shows the number of organisms in the ballast water during uptake into the ship before treatment, so around 100,000 individuals per cubic meter. The tiny red bar shows the measurement from the ballast water discharge after treatment, around 300 individuals per cubic meter. Now, the discharge standard in the regulations is 10 individuals per cubic meter. So in this extreme case, where there was a very high abundance to begin with, the standard was not met. However, there was a huge effect of treatment. We've taken similar paired measurements, so before and after treatment samples from a dozen different ships and different treatment systems in the Great Lakes, and we found an average about 60% of discharges meet the standard. But in all tests, we observed at least a 99% reduction following treatment. All of this information was put into a model to predict how the rate of spread of aquatic non-native species would change as a result of the Canadian regulations. And that model predicts a 70 to 85% decrease when all ships in Canadian waters use treatment. And if all ships on the Great Lakes were to use treatment, spread could be reduced by up to 99% throughout the Great Lakes. So we've found this effective treatment and level of risk reduction to be consistent with the research we've done on the coasts as well as in the Great Lakes. So in summary, there's quite a strong body of evidence gathered to document how treatment systems are working, the cost versus the benefit of their use, and all of this was taken into consideration when Canada completed its regulatory update. And I'll pass it to Colin.
Thanks, Sarah. So I'm going to speak from a policy perspective on how Canada's implementation is going following our 2021 regulations. The installation of ballast water management systems is progressing, with systems being installed by Canadian Great Lakes ship owners. I can tell you that while this isn't an easy task for ships, it is doable. And we do have mechanisms for flexibility in case of undue hardship. But the process of installing the technology is proceeding. So treatment systems are beginning to reduce environmental risks, just as Sarah explained. We knew that the use of ballast water management systems would be challenging on the Great Lakes due to the water quality there. In particular, the water is quite cold, and it sometimes has a lot of sediment in it. Those kinds of things make it difficult to use some of these treatment technologies. But we're encouraged that these challenges are declining with experience. And those that remain focus on certain seasons, early spring and late fall, as well as certain locations in the Great Lakes where the water quality is particularly tough. So to continue to support industry in addressing these challenges and advancing with technology in the Great Lakes region, Transport Canada is launching a ballast water innovation program to fund up to $12.5 million in industry-led R&D projects for the Great Lakes. And that project is going to run between now and 2027. So one of the questions we're getting asked a lot is how the EPA proposal would align with Canada's approach. We know that binational alignment is crucial for ships. They are mobile and they can't just change out their equipment or their approaches as they move through the Great Lakes. So let's not forget that when you count the 8 Great Lakes states, the EPA, the US Coast Guard, Transport Canada, we're talking about 11 different sets of rules, and that's very difficult for anyone to manage. The US federal legislation, the Vessel Incidental Discharge Act, or VIDA, works to set one set of standards in the US. And if we can also get to compatibility between Canada and this US standard based on feasible requirements, that's going to protect the environment and be very helpful. So looking at what's in alignment here, both Canada and the US currently require international ships to treat ballast water, and that's important in terms of reducing new invasions. We're very encouraged by EPA's proposal for an equipment standard, focusing on the proper installation, operation, and maintenance of technology. Our view is that despite the difficulties associated with treating Great Lakes water, that is what is reasonable. Installing and operating and maintaining this technology is what's reasonably under the control of the ship owner. So based on the science that we've just heard, taking this similar approach on both sides of the border would reduce spread of invasive species through the ballast water of Lakers. And that's great. And I want to emphasize that we agreed with those points of alignment. However, one area where EPA is still considering and in fact asking for feedback is on which ships will be required to treat their ballast water. So Canada has set a timeline for Great Lakes ships to fit ballast water management systems. Because recently built ships will find it easier to install this new technology, we are starting there, and we will require that ships built starting in 2009 begin treating their ballast water by the fall of 2024. And in due course, Canada's will require all Great Lakes ships to comply. We actually chose 2009 as the cutoff for recent ships to align with EPA's current regulations. EPA's new proposal would depart from that by regulating only ships built after the US Coast Guard finishes its regulation, likely no sooner than 2026. That would result in exemptions for recently built ships on the US side of the lakes. So EPA is taking public comment on whether to retain that current timeline, which would require all vessels built since 2009 to treat their ballast water. And this is one of the areas that Canada's looking at in terms of our comments back to EPA. So, oh, and I've lost my slide here. Let me just see if I can get it back on the screen. Just give me one sec. I'll blow it up again. Sorry for this. Full screen. All right. So I'd like to sum up this discussion with a bit more on our path forward, which is R&D to help with getting these systems installed on ships and working well. So our rule reflects a decade of studies and discussions with industry scientists and engineers, and we concluded that no other technology was waiting in the wings to meaningfully address this issue. We chose an equipment approach, seeing the large positive impact of treatment and to minimize the uncertainty for industry, and we've begun R&D work now to optimize this existing technology for the Great Lakes. For us, it's important to avoid repeating the science and technology work of the past, and we know that the perfect can be the enemy of the good. So going forward, our focus will be on collecting data from working ships that have this equipment on board in the seasons and locations where ballast water is commonly loaded. Our intention is to use that data to drive technology optimization, helping ships to use this available equipment more effectively and more reliably. We'll ensure that the lessons learned are shared across the Great Lakes. And we'll continue to implement this rule with feasibility and sensitivity because we know that we need to partner together with ship owners that are investing in this equipment to address the spread of invasive species. Because as you heard from Sarah on the ballast water science, working together is the best way to protect the Great Lakes. Thanks very much. And I believe we'll be able to take questions later on in the webinar. So I'll pass it back to you, Don. Thanks.
Thank you, Colin, and thank you, Sarah. Next up is going to be Molly Flanagan, Chief Operating Officer of the Alliance for the Great Lakes. I'm going to share her presentation here.
Looks
Okay,
good.
Molly.
Hey everyone, thanks so much for being here. Like Mark, I've been working on ballast water and invasive species issues for a very long time, possibly longer than some of you on this webinar have been alive. And as you just heard, aquatic invasive species pose a very real threat to the environment and economy of the Great Lakes. Canada has figured out a way to regulate all vessels operating in their ports. Next slide, please. We know there's nothing stopping invasive species from moving from one side of a lake to another. If the US doesn't regulate all ballast water, we put our lakes at risk and are still allowing potentially contaminated ballast water to move from lake to lake. Next slide. What the Alliance wants to see is simple. We want all vessels operating in the Great Lakes, whether they leave them or not, to treat their ballast water. You heard from Mark that ballast water is a way that invasive species get introduced and then spread around the lakes. We need EPA to regulate these discharges. Just like factories aren't exempt from the Clean Water Act, we don't want any of these large vessels to be either. Next slide. In 2018, Congress adopted the Vessel Incidental Discharge Act, which updated the way that the Environmental Protection Agency and the Coast Guard regulate a number of discharges from ships, including ballast water. Since we like acronyms, we call it VITA. This law requires the Environmental Protection Agency to develop new rules to implement it. Congress made it abundantly clear that the agency is obligated under the Clean Water Act to set rules for ballast water that protect the Great Lakes from damage from invasive species. And this isn't up for debate. The agency is working on those rules now. It issued draft rules in 2020, and at that time, the Alliance for the Great Lakes, along with environmental and conservation organizations across the region, requested that all vessels operating in the Great Lakes be regulated. The agency recently released additional information to the public about these draft rules, and they're requesting public comment right now. That's where you come in, and I'm going to get to that in a little bit. Next slide. One positive development is that the EPA is considering regulating ballast water discharges from new lakers. This should absolutely be required. There's no excuse for building a new laker and not including a ballast water treatment system on board. However, new lakers are rarely built. This is a photo of the Marc W. Barker, which was launched in 2022. She is a very beautiful ship, but it doesn't have a ballast water treatment system on it. Existing lakers, those currently operating in the Great Lakes, would be exempted under the currently proposed rule. Next slide. VEDA does not exempt existing lakers from regulation, but the Environmental Protection Agency is proposing to do that. The agency cites the estimated cost for lakers to install treatment as a primary reason not to impose the requirement to treat ballast water. Yet the lakers claim to support billions of dollars in economic activity across the country and that they're of national strategic importance. The laker industry has used this cause and case to argue to Congress for a $3+ billion redundant SULOC to be constructed at full federal expense. The SULOCs are located on the St. Mary's River and allow freighters to navigate between Lake Superior and the lower Great Lakes. This signals that the lakers and Congress expect these vessels to be in operation for decades to come, in part because of this federal subsidization of waterway infrastructure. With billions of federal dollars being invested in this water infrastructure, it's a small ask to have lakers who are benefiting from this investment follow the same rules that ocean-going vessels are already committed to. Next slide. If the immediate installation of ballast water treatment systems is truly impossible, then the rules should clearly outline the steps and timeline necessary to get from where we are today to a fully regulated fleet in the future. Just because an industry did not have to comply with a rule at the time it was built doesn't mean it gets to ignore that new rules in perpetuity. We wouldn't exempt an oil refinery or a steel mill or a wastewater treatment plant from the Clean Water Act just because it was built 50 or 100 years ago. If lakers want to operate on the Great Lakes, it's their responsibility to upgrade their fleet. The shipping industry has asked repeatedly for a number of years for uniform regulations for ballast water across the United States and harmonized with Canada. What the Environmental Protection Agency is proposing is not that. Exempting existing lakers carves out this class of ship from regulation and puts our lakes at risk. Most important, it fails to live up to our obligation to prevent new damage from the invasive species that have already cost the Great Lakes and the people who live here so much. Next slide. Now for the most important part, and that is how you can help. EPA is accepting public comments on this proposed supplemental to the rule until December 18th of this year. After this webinar, the Alliance is going to send you an action alert that you can fill out to send comments directly to the Environmental Protection Agency, asking them to regulate all discharges of ballast water. This will also be available on our website. So I hope you'll take action and then also share our action alert with your friends who care about the Great Lakes. If you want to submit your own comments, you can visit www.federalregister.gov. And then if you type vessel discharge into the search bar, you'll get probably as your number one response, Vessel Incidental Discharge National Standards of Performance. That was published on October 18th, 2023. If you click on that, you'll be able to see the entire supplemental. And if you want to submit comments, you can do that from that website if you don't want to do that via our action alert. So I really appreciate you all being here. I hope you'll take time to take action, and I will turn it back over to Don to manage our question and answer.
Okay. All right, thank you to all the presenters. Now it's time for questions. Again, please put them in the Q&A box, not the chat box. We also received several questions via email prior to the session, so we'll be starting with those. And let's get going here. Let's see first, what is being done to stop the spread of invasive species beyond the focus on ships? Marc, you want to take that one?
Sure. There are a lot of ways that invasive species can come into North America and also to spread around. And salties was one that I talked about, and then the Lakers within the lakes. Another is the trade of live organisms. So the pet industry, for example, there might be an exotic species from far away that would look good in an aquarium or wherever. There's not a lot of risk assessments that go on before those importations are allowed. So we've at the Fishery Commission and a lot of others have been arguing for the need to do more risk assessments and essentially treat these species as harmful unless proven otherwise. There's also the spread potentially from recreational vessels. The Sea Grant programs are doing an excellent job, in my view, on educating people about why it's important to clean their boats and drain the tanks and to dry them out before they move them and inspect them from one water body to another. So there is a role that citizens can do if they're moving from one water body to another. Bait as well is another possibility. It's very, very hard to distinguish very little fish from one from another. The bait industry does a decent job on trying to make sure that the bait is pure, but there could be contaminants with some species in there. And probably the biggest poster child right now that we're dealing with is the movement of species through waterways. These could either be natural waterways like rivers or man-made canals like the Chicago area waterway system. We know that the Great Lakes are a donor of invasive species to the Mississippi River system through that Chicago area waterway, and then they can spread throughout the country. We also know that the Chicago water system south of the Great Lakes could allow for species into the Great Lakes. The invasive carps being kind of the really key that we're working on there. So those are the other things that are possibilities. For the carps, there's a very large project going on outside of Chicago at the Brandon Road Lock and Dam to try and bolster that pinch point so that the carps would be blocked from moving from the Mississippi River system into the Great Lakes Basin. But the problem is that once a species gets into a system and starts reproducing, the problems often get worse, not better, because the species make more of themselves. So we really, really need to focus on prevention in the first place.
Anyone else have anything to add? Molly, you want to talk about what the Alliance is doing?
I would just echo, Marc mentioned the Brandon Road Lock and Dam near Joliet, which we're working to get protections placed on to stop invasive carp from moving to the Great Lakes. That is one way in which invasive species can actually move to and from the Great Lakes. So that's another really important issue that we are working on, and you're welcome to follow us on that issue if you're interested.
Great, thanks. Okay, here's another question that came in. Why is it important to regulate ballast water in the US and Canada? Are the same ships operating in both countries? I think that sounds like it should go to Colin.
Yeah, I'd be happy to touch on that. And Sarah touched on it in her presentation as well. So yes, we do have ships operating between US ports, we have ships operating between Canadian ports, and we have ships operating across the lakes in these bodies of water. And so our maximum protection for the Great Lakes will be if all of these ships, which are operating in these shared lakes, are all treating their ballast water. Sarah, did you want to add anything to that? Okay.
All right, thanks for that. Here's another question that came in while I'm look here. How has the fishery suffered from invasive species?
Yeah, I'll take that. So the Great Lakes fishery is a multi-billion-dollar resource, and we have about 150, 180 native species in the Great Lakes, and some that have also been introduced or naturalized. on purpose, some of the salmon species, for example. But we have a lot of very valuable species, whitefish, trout, walleye, sturgeon, many different species, both commercially and recreationally important, and also for subsistence and indigenous fishing. Invasive species exert essentially a top-down or a bottom-up effect on the fishery. So the zebra mussel was an example that I used, but I'll use the invasive carp as well. Invasive carp actually feed at the same trophic level or the same place in the food web as the mussels do. They're planktivores. So you get those big charismatic carps doing the exact same thing to the ecosystem that the zebra mussels and quagga mussels are doing. And that's filtering out the plankton and essentially robbing the ecosystem and everything that's dependent on it from that food source. Zebra mussels also, as an example, coat the bottom. So that's habitat destruction. That's linked to the loss of some small critters in the Great Lakes that the fish rely upon, and have been linked to poor condition in some fish species like whitefish, which is a commercially valuable species and certainly recreationally valuable. The lamprey is the greatest example of the top-down effect. Before lampreys were brought under control, they were killing about 5 times the commercial catch in the upper Great Lakes of species like lake trout. So the lamprey control program, which began in the late 1950s, has been very successful in driving those numbers, lamprey numbers down. We've gone from losing about 110 million pounds of fish to lamprey to less than 10 million pounds a year. So those are just a couple examples, but I would really stress some food web disruption, both top down and bottom up throughout the Great Lakes Basin.
Thank you, Marc. Another question that came in is, how do we know lakers are spreading species around the lakes? I feel like that sounds like something Sarah might want to answer.
Sorry, had a bit of a delay there. Sorry, can you repeat the question one time?
Yes.
The
How do we
question
know?
was-
How do we know lakers are spreading species around the lakes?
Yeah, okay, thanks. So there's been a number of studies, some conducted by my team and some by some US researchers, where they've actually collected samples of ballast water and ballast sediment from tanks of ballast tanks of lakers, and have found species being moved from one port to another port where those species are not found at the recipient port.
All right, another question, and this will open up to anybody else. How does water temperature have an effect on the ballast water management systems?
So I can, yeah, go ahead, Sarah. Yeah, please do.
Okay, I'll speak to the biology and you can maybe speak to the operational side.
Sure.
So we have done some research on like cold water effects on the different treatment technologies. And for chlorine, for example, the chlorine degrades naturally through time in freshwater or seawater. And what we find at cold temperatures is that the chlorine degrades much more slowly. So actually the treatment is much more toxic in cold water, which means the neutralization step is very important when we're talking about use of chlorine in the winter, for example. We haven't seen strong effects on UV treatment based on temperature when we're talking about the biology of organisms.
Yeah, so I don't have a lot to add to that, but I would point out that ships do need to select an appropriate treatment system for their operations. And a lot of the treatment systems that are out there do have a chlorination component. So it really reduces the number of treatment systems that may be applicable to a certain ship or a certain Great Lakes environment. So it restricts the choice that ships have in selecting a treatment system. And that adds to the challenge when you put it in combination with some of the other water quality factors. So, you know, fresh water, for example, as well, a lot of treatment systems out there will generate chlorine, again, chlorine, from seawater, but that's not something that you could do on the Great Lakes. So when we talk about the Great Lakes being very challenging for treatment systems, that's partly including the need to select an appropriate system. And temperature can also bring on challenges like slush in the water. If you're trying to filter, if you're trying to run water through mosquito netting, which is, maybe a low-tech way of describing what the filtration step in a system is like, that's one thing. But if you're trying to pour ice cubes through that mosquito netting, you're going to have a very different result. So temperature can play a role in some of those circumstances as well. And that's why some of those effects are more seasonal.
Thank you. We have another question. Open up for everybody. What about these methods will be affected by global warming or climate change in the lakes? Will it have any effect?
Well, I can sort of start on that, but I think then I would probably pass it to Sarah. We know that invasive species pose a greater risk if they're able to tolerate the conditions at the point of discharge. So let's imagine now a salty coming in from, a very warm part of the world and bringing with it an organism that perhaps likes to live in tropical waters, and it's being discharged into the Great Lakes, which tend to be very cold. If we start seeing warming of the lakes, and you never know how close that organism is to being able to survive in the Great Lakes conditions. So if you warm up the Great Lakes by a few degrees, then suddenly you may have a new group of organisms that are coming in that may pose a greater risk. And similarly, when you're talking about the spread of invasive species, you may have species that are sort of specialized to certain environments within the lakes. And if those environments change, then we may be susceptible to greater spread. So bringing in a ballast water treatment standard and ballast water treatment systems, both for salties and for lakers, the perspective in Canada is that we're controlling for those risks, because instead of just trusting that the lakes are too cold for these species, we're now saying we're actually taking those species out of the water so they can't be introduced. Sarah, would you like to add anything to that on climate change?
I guess just an expansion that if you're talking about the treatment technologies themselves, we think most of the challenges with the treatment technology have to do with colder water or with really turbid water. So if climate change is warming the water or somehow affecting the turbidity level, there could be impacts on how effective the treatment systems are. But in terms of temperature, most of these treatment systems are type approved at warmer temperatures. So maybe treatment will work even better for warmer waters.
Great, thank you for that. Let me see here. Okay, here's another question from an attendee. That even if you can reduce the number of organisms to the set standards, can that lower number still cause a problem with invasive species for the lakes?
Yeah, I'll take that one. So yeah, we know that lower is better, but it doesn't necessarily mean invasions won't happen at all. So reducing the number of organisms that are discharged in ballast water, we want to get that number to the lowest possible. The fewer ones that get introduced, the lower the probability that they would be able to establish and set up a population in a new location.
Okay, and this question is about cost, and how is cost of implementing this technology kind of the biggest barrier for wanting to implement ballast discharge management systems?
Yeah, that's a good question. I think cost is a very important factor. I do think we have to realize that these are significant investments that vessels have to make. And so cost is certainly something that has come up in the discussions that Canada has had with our ship owners. But I think that from our perspective, we ran a cost benefit analysis and demonstrated that those investments would yield significant environmental benefits to all Canadians. And that's the basis on which we went forward and regulated. That being said, we do have a timeline that spreads the installation of treatment systems over a significant period of time. We're starting with the vessels that are more recently built because those are the ships that were designed, if you will, sort of in the era of ballast water management. These are ships that in many cases were designed recognizing that they would need a treatment system in the future. And so they're ships that ought to find it easier to get a system on board. So that's why, to address some of those cost considerations, we have focused on those more recently built ships first, and that we've provided some additional time for the older and more challenging ships to, that were not designed with ballast water management systems in mind, to begin to install and install this equipment. But certainly, I don't think we've been quite clear that these are significant investments for ship owners, and so we recognize the challenge of that investment in environmental protection, because at the same time we need to address the environmental risks that these ships pose. I'm not sure if anybody else on the panel would want to speak to that, but that's kind of the Canadian consideration.
I'd like to weigh in on just the other side of it too. And if we don't address these problems, these costs are borne on the citizens of the people of the region and the taxpayers. So there are costs, certainly, but there are also ecological costs, lost fishing opportunities, irreversible environmental damage that's unethical to inflict on a system. And somebody will bear those costs. And the way invasive species policy seems to go is just foisted on the taxpayers or foisted on the people who fish the Great Lakes or benefit from the Great Lakes in some other way.
Great, thank you so much. This sounds like a question for Molly. Let's say I lost it here. So attendee wants to know why the James R. Barker does the treatment system for a new ship. Can you reiterate why new ships don't have treatment systems like the Barker does? Is it just too new a concept?
Certainly the concept of ballast water treatment is not new. And I was also surprised that the Mark W. Barker doesn't have a treatment system on board. I think that's a really lost opportunity to put ballast water treatment on a laker. I don't know why Interlake decided not to do that. Yeah, I would just say, like, I don't know why they chose not to, but I do think it was a missed opportunity.
Thank you. And then an attendee asks if these slide decks are going to be available for after the webinar.
Certainly the recording of the webinar will be available, and we will be circulating that to participants after this webinar ends.
And then I have a question here about, let me get there. Harbors of ballast origin in the lower lakes. Will they be monitored for high-risk species and subject to uptake and transfer? Will those infested with known invaders not yet in Lake Superior be regarded as high-risk ports of ballast origin?
I don't think we know the answer to that. I mean, I think the monitoring of invasive species is really critical, and we should be definitely investing money in that, as well as monitoring of ballast water discharges from vessels that do have them on board. I do think it makes a lot of sense if an invader hasn't been found in a lake. So if it's in Lake Erie, but it isn't in Lake Superior, then certainly we should regard ports that are taking ballast water discharge in Lake Superior as high-risk ports.
It's got a couple more questions here that I want to hit. One is on, have any of the recent infrastructure bills in the U.S. included the potential for funds to help with Great Lakes protection initiatives? I'm assuming like IRA and things like that.
Is that?
I'm not aware of any of those funds being eligible, for example, to help with a ballast system. Maybe Molly knows, but otherwise, it's there was a shot of money under the infrastructure on the U.S. for the Great Lakes Restoration Initiative. And there are a whole number of very important invasive species projects under the GLRI. Not the least of which are the invasive carps work. They're supporting sea lamprey work and many other invasive species things. But I'm not aware of any direct dollars under that for, say, to help with ballast technologies or treatments. And maybe Molly would know better.
No, I mean, there is funding going to the University of Wisconsin Superior to do some work looking at ballast water systems and how they might work on Laker vessels. So that's like a really important investment that's being made in ballast water treatments system research. But I'm not aware of anything else particularly related to that.
Okay, looks like about it for our questions. Does anybody else have anything they want to add from the panel? Okay, then
Thank you very much.
thank you for your time today. And look for more information about ballast water and this webinar in your inbox. If you remember the media and you have further questions, please feel free to reach me, Don Carr, Media Director at the Alliance for the Great Lakes at dcarr@greatlakes.org. Thanks, everyone. Great job. And if no one else has anything else to add, I think we're done today.